Okay, so some important things here. We've got, this is in the middle. I've already posted the first part that you missed. You can watch it on YouTube. Okay. So can you see that if you turn this and had a rotation about the center of this object, if you turned it, it eventually would match up with itself again. In fact, you could turn it this much. You could turn it so that point matched up with that one. You could turn it so the point matched up with this one. You could turn it so the point matched up with this one. Or you could turn it so that the point matched up with this one. Yes, you do have to write some spots in your notes. So you have to write, a shape has rotational symmetry when it coincides with itself after a rotation of less than 360 degrees. So if the only way you can have it be symmetrical is if turning it 360 degrees and matching up with itself, we don't really say it has rotational symmetry. That's right. So this one, and that's why I put all the arrows there. If I rotate it, right, if I draw it like this over top, let's see if this works. So you can watch it. Take that shape. Can you see if I take it and I rotate it, bing, it matches up. Bing. It's very important, the sound effects, right? Bing. And, yeah, you can't see the notes. I'm spinning around. So this is what rotational symmetry looks like. It's like rotated in a circle, and if it matches up as you're going, we say that it has rotational symmetry. A square would have rotational symmetry. And of course, this one, right, if you rotate anything 360 degrees, it gets back to itself. Now, one of the things that we're going to learn is that an object has an angle of rotation. In other words, how much do I have to, I'm going to take this shape again. Let's say I turn it till it matches up the first time, right there. How much did I rotate it? Any guesses? Looks like less than 90 degrees, right? So we have to figure out how much we turned it in order for it to match up again. That'll be one of the challenges that we do. And you're right, the answer was 60 degrees. Because you return it 60 degrees once, it matches up. 60 degrees again, this would be 120 degrees. 60 degrees again, 180, which makes sense that if you turn something halfway around, you have 180 degrees. Then 240 degrees, then 300 degrees, and then 360 would be back to where we started. So in this one, when we checked 60 degrees, every time we did 60 degrees, it matched up, and it all the way around got back to 360. So how do we describe this, and what is this all called? And it's nice and slow. I'm pretty sure I switched to the next slide. I'll try again. There we go. The number of times a shape coincides with itself, and this is an important definition, is the order of rotation. So on that star that we just turned around the last time, we would say its order is 6, because it was 6 times until it got back, 6 times that it matched up before it got back to where it started from. And the next important definition is the angle of rotation. And there's a nice formula for this. So you guys figured out that the first one was 60 degrees. All you would have to do in that first one is take the whole circle, which is 360 degrees, and divide by how many times it matched up, which is 6. 360 divided by 6. that first shape would have an angle of rotation of 60 degrees. So there's a formula that makes sense, but you'll have to know that for quizzes and tests, okay? I don't think that one's on your formula sheet.
Can I add it?
No, you just have to add it in here. So does this make sense? That if you had something that only, right, what we're going to do in between here is put the formula in. So 360 divided by 2, that would make 80. The next one, 360 divided by 3, that makes 120. Next one, 360 divided by 4, that would make 90. 360 divided by 5, that makes 72. And 360 divided by 6, which is the one we started with, makes 60 degrees. So we never say something has rotational symmetry of 1, of order 1. The smallest it can have is order 2. And that means you rotate it 180 degrees, matches up, rotate 180 degrees, back to where you started. How about the letter S? Okay. Here is how to cheat with rotational symmetry. You take a piece of paper and put it on top of your test. You can see through a piece of paper and you'll be able to trace, watch this, I can trace exactly the shape that I started with. You're allowed to cheat this way. Okay? You take a piece of paper, you trace over top. Then you choose where you think the center is. This looks like the center. Then you take your piece of paper and rotate it and see if it matches up. So I take it, bing, look at that, matches up there, and then back to where I started from. So this one, what can we say? We can say it has an order of 2 because it matched up at the bottom and then matched up all the way around. And the angle of rotation then is 360 divided by 2, which is 180 degrees. So, because sometimes it's hard to figure out, does it actually have rotational symmetry unless you actually take a piece of paper. So I'm gonna trace this out. Okay. Take the paper. I'm going to rotate it 180. Does it match up?
Yeah.
Yes, it does.
So that's a 2 order.
So this is order of 2 and angle of rotation of 360 divided by 2, 180 degrees. Now, I think this was supposed to be drawn with the same thickness. On mine, it looks like it's narrower at the bottom. But it looks the same on yours? Okay, good. So I take that shape, rotate it, bing, once, twice, 3 times, 4 times. So we would say the order is 4. The angle of rotation, if you use the formula, it'll be 360 divided by 4, 90 degrees. So far, so good. Do you like this? Easy? Okay, excellent. Ooh. Now,
But technically, if you look at it, the colors are different, so
Yeah, like it would match up nicely here, right? But the colors don't match up. So no rotational symmetry. But do you see how it kind of does? Yeah. So it kind of does, so it makes it nice to look at. A lot of symbols that have symmetry are nicer to look at compared to symbols that don't have symmetry. Oh, and this one we did already. What did we figure out the order for this one? 6, and the angle for this one? 60 degrees. Perfect. Okay. What do you think? Bing. Well, now, what am I doing? What has the computer done on mine that makes it wrong? The center that the computer chose isn't the actual center, but this one, so that's where when you draw it, you have to kind of like figure out where you think the center is approximately. This one actually has an order of 5 and an angle of rotation, 360 divided by 5 is 72 degrees. Well, let's try it. Because this is longer, right? No, oh, not quite, eh? So we tried it. This one has no rotational. Does it have any symmetry? Where? If you smack, I like that. If you smack it in the middle this way, but not this way, not vertical. It has a horizontal line of symmetry, but not vertical. But no rotational symmetry. Now, sometimes they're going to give us an object and ask us to rotate it. And again, you can use this cheating method I actually have if you want more effective. This is like tracing paper where you can see through even better. So if you're like, ooh, could I get some of that special paper for my quiz? I can cut a slice of this for you. Special tracing paper. Okay. Another definition for us. A vertex. And now we have 4 questions for rotating about a vertex. So what does this look like? Okay. We want to rotate the following shape 90 degrees. Do you know what clockwise means? Okay, so think about a clock. Wow, that's a yellow clock. We'll change it to black. Here's a clock. Here's 12, 3, 6, 9. Which way does time go on a clock? Like that. So that is clockwise. And anytime you go the other direction, we call it counterclockwise. So we want to take this point, C. Again, you can trace over top of your triangle, and you want to rotate it clockwise 90 degrees. So what you're going to imagine, okay, you've got it traced. At point C, I'm going to draw a little crosshair at point C. Does it make sense that we want to rotate 90 degrees? I put an arrow turning it that way. So what you would do, and the computer won't let me do this nicely, but you would trace it. Then you would put your pen or finger at this point right here, and you would turn it 90 degrees. So I put my finger here, and I turn it down this way 90 degrees. Okay? What would it end up at? Can you imagine it? This part turned 90 degrees. 1, 2, 3, 4 is now, I'll do my final answer in purple. 1, 2, 3, 4.
Oh, so that's literally what the question is. It'll be a question like that.
It'll be a question like, turn it 90 degrees, right? And then this point, you would see, oh, it goes to there, and it goes to there. And the way that we label our final graph is, this was point B, so we write a B there, but we put a little dash beside it to say that it's the new B point. This is your new A point, and this is your new C point.
Wait, how far does the
Yeah, the computer's off for me. Now, all the distances between the points stay the same. So this, can you visualize that this dotted line right here on the blue, when you rotate it 90 degrees clockwise, would become this dotted line in the purple? And again, you have a little piece of tracing paper or a little piece on top. You turn it, see what the new shape is, and draw the result. Okay, same one. Here's my original shape. I would draw A, B, C. I'd do tracing paper. I would trace over top of this. And now I'm rotating around B. So at B, I draw little crosshairs on B, because that's where I'm going to rotate. I'm going clockwise 180 degrees. Which is clockwise? That would, if I start on this side, 180 degrees clockwise, can you see that that would go like this? Okay? Almost flip the shape. When I take it, I hold my pen there and I trace it. Can you see that this would go to there? This one would get down to there and to there, and this would be your C prime, this would be your A prime, and this would be your B prime. So you're taking this is what I'd imagine, taking this point C. Okay, oh, does this help you imagine it? Can you see if I take this and rotate around that point, it'll go like that? Can you see that? And again, does the tracing paper help a ton? Absolutely. Can some people do it in their heads? Yes. But that's the next level. That's what you're trying to. Can you train your brain to do this in your head without the tracing paper? Right? That's harder. And what you're developing while we're doing this is called spatial mathematics. The ability to see shapes in space and turn them, rotate them, see what they look like as a result. This is called isometric paper. Notice the dots are different on this one than a regular graph. Okay? The angles between any dots on this one, on this type of paper, are 60 degrees. So now we're going to take the original shape, you're going to trace it out on with a piece of paper above it. So, yeah, blue paper. Where are we doing it? Around F. So I go to F and I draw my crosshairs. Notice my crosshairs don't match up with the dots. Okay? and we need to go 120 degrees. Right. So
It doesn't matter?
I'm going to add counterclockwise. Technically, the rule is if it doesn't say, it's always counterclockwise.
But if we forget it and do clockwise, is that fine?
That'd be, well, you can, if you forget, you can ask on a test. And it says, it doesn't say, should it be clockwise or counterclockwise? And I'll tell you. Okay? So, can you see that if you rotated something, 60 degrees would be 1 dot, 120 would be 2 dots. So we need to take this line, which right now is how many dots wide? 1, 2, 3, 4. 4 dots wide. And you rotate it 1 set of dots, 2 set of dots. So now we go in the purple graph, counterclockwise, 1, 2, 3 to there. This will be G prime. What's happening is this is going
Wait, what?
to there.
I thought you said 1 dot was 60 degrees.
Right? So this would be 1 dot turn. This would be 2 dots turned.
But wouldn't that be 4 dots?
No, because you went, here's, let me take a yellow dot. Let's take this dot right here. This would be 1 dot turn. This would be the second dot turn.
Oh, so you only put it on like until the bottom, or?
The dot has to be the same distance away. 1 dot turned, 2 dots turned.
That makes more sense.
Okay? So that's 120 degrees. That will be this line here. Okay, we need to draw the other lines. This one, and sometimes, see this one that is 2 dots long here, rotating once, rotating twice. It's now 2 dots long there. These ones that are 1 apart are there and there.
That just doesn't look even, though.
And it might be on mine screen, it's because the photocopy or the computer screen is a little bit off. On yours, it should work out perfectly because the dots are strategically drawn.
On ours, it works.
Yeah, mine it looks a little bit weird, and that's because of the resolution from the computer to the projector is off. If I draw a perfect circle on my computer, it actually looks like an oval on the screen. And if I draw an oval on the computer, I can make a perfect circle on my screen, which is really frustrating. You'd think they'd figure it out, that you want to draw a perfect circle there, it should be a perfect circle on the screen. All right, back. Here we've got the funny angles again, right? Can you see that the paper is the 60-degree one? But we're rotating this 180 degrees about the vertex F. So again, I could take a paper out and trace over top of this. I can draw my crosshairs on F. I want to go 180 degrees clockwise. Can you see that clockwise would go this way? So this is 1, 2, 3, 4, 5, 6, 7 away. When I do that, it'll be 1, 2, 3, 4, 5, 6, 7 away this way. This is 2, 2 there. And we can label this. This was G. This is now G prime. This is E prime. And this is H prime. And of course, since we rotated around F, F would stay the same. So again, this is our last one, right? Trace it out. We're rotating about the vertex H, so we can make our crosshairs on H. We want to go 270 counterclockwise. So one thing I like to do when I'm drawing my 270, first of all, are you okay? I'm going to draw the crosshairs here. Are you okay that this three things would be 270 degrees? 90, 180, 270. Okay? Now, I started here because I had a line on that part. So if I started there and did on my paper and drew 270, my final graph, my h to I, will now be, how many apart is it? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It'll go straight down as a result. Junk, junk. And this part will go this hurts the brain sometimes, right?
A lot of the time. Yeah. No, I just but on the test, right? Is the graph paper gonna be
Either the 61 or the regular one.
tell us?
Well, I'll give it to you. It'll be on your test drawn out.
But how would I know?
You have to be able to, well, this one, because they all match up, see how they all match up straight up and down and straight across?
Yeah.
Those are all 90-degree turns. But the one that we did before, notice that they all match up like that.
Whoa, brain hurts, yeah.
Then that's a 60-degree turn.